My name is Mudavat Lakshman, and today, as a part of AAT Tech Talk, I'm going to deal with the subject object oriented software engineering with the topic blockchain based voting system. Okay, so the motivation is like, why do we need a voting system first? We have to come to this point. We have to talk on this point first. Trust in elections is decreasing in digital systems. Centralized systems can be hacked or manipulated. Manual voting is slow or resources heavy. So need a system that is secure, transparent, tamper proof. That will blockchain provides a strong solution for that. Okay. One important issue in current system is lack of trust. Even if the system is secure, people may not believe it because they cannot verify it themselves. Blockchain solves this by allowing public verification without revealing identity, which increases confidence in the election process. Now we move to the introduction and problem statement of this project. So the problem is traditional voting system rely on centralized authority, trust in a single point of failure. So the solution is a decentralized, immutable, transparent system will be the solution for this problem. Okay. So why object-oriented software engineering for this? A blockchain is inherently object-oriented, right? That is, blocks are objects and chains are collections, transactions are messages. OOP principles ensure modularity and security. So here, in centralized systems, a single authority controls the database, which creates a single point of failure. If that system is compromised, the entire election can be manipulated, right? Blockchain removes this dependency by distributing data across multiple nodes, making it extremely difficult to attack or alter. So the requirements of the engineering is the functional requirements and the non-functional requirements will be there. So voter registration, cast vote, tally votes, these are the functional requirements, and the non-functional requirements are immutability, transparency and integrity. So non-functional requirements are actually more critical here than functional ones, right? For example, immutability ensures that once a vote is recorded, it cannot be changed even by the system administrators. This property is achieved using cryptographic hashing, which links every block securely. So why blockchain? We are going to discuss why blockchain is ideal, right? Because data is immutable, distributed across multiple nodes, no single point of failure, uses cryptography for security. So every vote becomes a secure transaction. So here each block contains a hash of the previous block, forming a chain. If someone tries to change one vote, the hash changes and the entire chain becomes invalid. This makes the system tamper evident, which is a key advantage over traditional database, right? So the object identification. What is the object identification of this project or this problem? So we can say this is a very important step in object-oriented software engineering because identifying a correct object ensures proper system design. If objects are poorly designed, the system becomes difficult to maintain and extend, right? So the noun extraction strategy will be followed here. So that is identifying candidates for classes from the problem statement. Key objects identified: voter, candidate, vote, block, blockchain, miner. These are all the objects we are identified, and the class design will be discussed now. So each class represents a real world entity. For example, the voter class represents an actual voter, while the block class represents a container of transactions. This maps between a real world and software design is the strength of object oriented programming, right? Or we can say OOP. So here we have some attributes of voter class. We have voter ID, public key, private key, has voted or not. So this is a boolean one, right? If it's voted, then will be true, and or else it will be false. The methods are register, sign, vote, verify. And the candidate class have some attributes. Those are candidate ID and candidate name. And the method is get count to get who is a winner in this voting, right? So that will be thing. And we have transaction and block classes. So every class has its individual attributes and individual methods, which contributes more to get a secure and efficient voting system, right? So yeah, we have the ledger here is blockchain. So that will be the ledger of this voting system, right? So next, the sequence diagram, casting a vote. How, like, the actors are voters, blockchain interface and block, right? These are the actors, and the flow will be voter's request to cast vote, and the system validates voter ID, voter creates voter transaction, that will be private key, right? And the system adds voter transaction to pending transaction pool, miner creates a new block, blockchain adds block to chain, right? So here is the working flow of blockchain based voting system. How the voter will be registered. He will be registered digitally, and then user authentication will be done, and he will cast the vote, and then vote will be validated by the system, and the vote as a block. So it will be block, right? It means it provides a fully cryptographical things. It will be fully encrypted, and no individual will be come out, or no individual will be shown up, right? And then blocks added to the blockchain, and distributed verification will be done, and then real-time vote counting and results announcement will be done. So the mining process ensures the block are added only after validation. This introduces computational difficulty, which prevents attackers from easily modify the blockchain. The concept is called proof of work in many blockchain systems, right? So here we're also going to do like what is encapsulation and inheritance, how the encapsulation and inheritance is helping or contributing in this, right? So encapsulation ensures that sensitive data like private keys are never directly accessed. Instead, control methods are used, which increases security and prevents unauthorized access. So here encapsulation is used for protect the sensitive data, that is voter's identity, right, and hide internal details. Example, private voter ID, controlled access via methods improves security and data integrity, right? And when we come to the inheritance part, so inheritance helps create reusable structures, extend system features, right? So inheritance helps us extend functionality. For example, an admin may have additional permissions compared to normal voter, and this can be easily implemented using inheritance. Next, the concept of polymorphism will be added, like it is a main concept in the object oriented system or object oriented program, if we can say. So the polymorphism allows flexibility, so the same function can be behaved differently depending on the object. This reduces code duplication and makes the system adaptable to changes. And the abstraction, so abstraction is important because users not deal with the complex blockchain operations. They just click vote, and internally the system handles encryption, hashing and validation. So we got it that how these OOP concepts like we can say encapsulation, inheritance, polymorphism and abstractions are used in this voting system, so that the object oriented programming is really ensures that the security and efficiency of the voting, and how the cryptographic things works in the voting system, and how the abstraction is done, and how the flexibility is allows the function of different depending on the object, right? So this will be done. And next we go to the system architecture. So how the digital layer will be like how end user approaches the system, right? So the front end, there will be a front end that will be directly interacted with the user interaction, and there will be a back end that handles the voting logic. And then blockchain layer will be there that stores the voting votes securely, and optional database that stores the user details. So right, so the layered architecture improves maintainability. If we want to update the UI or change blockchain logic, we can do it without affecting other layers. And how it works, now we'll see how the workflow will be done. So each step in this flow ensures security. Verification ensures only valid user vote, right? Blockchain storage ensures immutability. Automatic counting ensures transparency. This combination makes the system both secure and efficient. So this is the workflow. And next we go for the security mechanisms. So digital signatures ensures that the vote is authentic and comes from a valid user. Hashing ensures that the data cannot be altered. Together they provide both authenticity and integrity. And now we talk about the advantages and limitations of this voting system, we can say blockchain voting system. Okay, so advantages are this is highly secure, transparent systems, and no central authority, faster results, trustworthy, right? So one major advantage is that trust is shifted from humans to mathematics, and cryptography is happening here, right? So making the system are more reliable. The limitations we can see these are complex implementations will be there, like we are using cryptography, we are using blockchain, so there will be like there's absolutely there will be some complexity, right? So although the blockchain is secure, it is still evolving. Issues like scalability and energy consumption needed to be addressed before large scale adoption will be done, right? Next, real world relevance. So the real world relevance are e-governance systems, national elections, university elections. We can use it on online polling systems. The future of digital democracy will be increased by these blockchain voting systems, as the democracy will be digital, right? The countries and organizations are already experimenting with blockchain voting, especially for smaller elections like university or corporate voting systems. The conclusion of this project, and that is, in summary, we can say this system is not just about voting but about building trust in digital systems using object oriented systems and blockchain technology, right? So here, this is like a half reference this from the software engineering books, and geeks for geeks, mdn, w3 schools, and IEEE, ASM, and all this. So this is all about the blockchain voting system. Thank you.